Hi, this is the third lecture on Laplace application. In this example, it's required to find the transfer function and the transfer function between the output voltage and the output current. That's the output voltage and that's the output current. So to find that, we got to find the equivalent circuit in Laplace. How we'll do that? All right, let me just refresh your memory about the element of electric circuit. When you have a resistor R and the relationship between the voltage across the resistor and the current, V of t is equal R I of t. And if you convert this to Laplace, there's no change. So the resistance is still the same, R. If you have an inductor, so you have L and you have the voltage V across L and the current, you know that the relationship is the voltage is equal L di by dt. If you take the Laplace, that will be Vs, and that's L. The differentiation will multiply it by S. So the relationship between the voltage and the current, SL. So in Laplace, you replace L by SL. So L used in time domain when you are using V equal L di by dt, and SL it's used in frequency domain, in S domain, when you are going to say that the voltage across the inductor is equal SL times IS. What about the capacitor? That's the voltage across the capacitor, and this is the current. So you know that I is equal C dV by dt. In S domain, IS is equal C, and the differentiation of voltage will be S V of S. So if you find the relationship between the voltage and the current, so that's the voltage will be equal 1 over CS times IS. So the capacitor is equal 1 over CS. So that's the impedance of the capacitor in S domain, 1 over CS, and that's the impedance of the inductor in S domain, SL, and the impedance of the resistor is still the same, equal R. Saying that, we can now find the equivalent of the circuit in S domain. So let's go ahead and move it here. So 2 is still the same, and that's the capacitor as you see it. It is 1 over 2S, and that's SL is equal S, and that's the 4. So you can tell that 1 over CS, it means the capacitor here, C is equal 2, right? And here L is equal 1, because this is LS, all right? So it's already, the circuit already transformed to the S domain. How now can you find the transfer function here? Well, the voltage here in the 2 ohm is equal the current I2 times 2 ohm. So the voltage is equal 2 times I2. Of course, we're working in S domain, but we're not going to write I2 of S. We know it's of S domain. So the question now, how to find I2? Well, I2 in this circuit, you can use current division, because I not going to the node and divided into I1 and I2. So this branch is parallel to this branch. So if you have 2 branches in parallel, and the current here going is I0 and the current here I2, and here I1. All this one Z1 and this is Z2. According to the current division, I2 is equal to I node, the I total going to the node here, times the opposite impedance, which is equal Z1 over the sum of both. So that's I2. And once you get I2, you can just multiply it by 2, you give V output. So V output is equal to times I2. And you need to divide, it's required to find the transfer function, the output voltage, or VO, divided by O. What is VO? It's 2I2. Well, so 2, and I2, it's equal to that. So equal I naught Z1 over Z1 plus Z2, and all divided by I naught. This cancel with this. So the transfer function h of s, which is in the question, will be equal to Z1 over Z1 plus Z2. We're not done. It's just we got something to help us. So we need to find Z1 and Z2. Z1, remember, this is the branch Z1, the opposite one, this one. So this Z1 is like the series S, the inductor and the resistor, S plus 4. So that will be equal S plus 4. And Z2 equal to the capacitor in series with the resistance. We have 2 plus 1 over 2S. 2 plus 1 over 2S. Let's simplify this one. We have 2S here, multiply 2 by 2 will be 4S plus 1. So that's Z1, Z2. If you add Z1 plus Z2, you will get, that's S, Z1, S plus 4, and Z2 is equal 4S plus 1 over 2S. You can simplify that by having a common denominator 2S, multiply 2S by S will be equal to 2S squared plus 8S plus 4S plus 1. That will have 2S squared plus 12S plus 1 divided by 2S. So that's Z1 plus Z2. And you have Z1. So we'll just go ahead and substitute in this equation. H of S is equal to Z1, 2 times Z1, okay, S plus 4, divided by Z1 plus Z2, we have it here, 2S squared plus 12S plus 1, divided by 2S, so we'll have 2S in the top here. Almost done. So you have 4S times S plus 4. You can, all right, and on the bottom here you have 2S squared plus 12S plus 1. So that would be the transfer function that was in question. Of course, you can simplify, you can factorize, but that's, I mean, general, the solutions required. Okay, I hope that was helpful.